Howdy, everyone. It's time for a webinar. Eh? Eh? Good. All right, so let's first go around and tell you why you're here. You are here to talk about the future of, I believe, what were we saying, Clay? The future of Kubernetes observability for SRE and operations teams, which is a fascinating topic that I'm super excited to talk about today. First off, let's go around the room and introduce ourselves so that our wonderful attendees can know a little bit about who they're talking to. I am, as always, Austin Parker, Head of Developer Relations here at Lightstep, and my co-hosts are, start with Clay.
Hi, I'm Clay Smith. I'm a product manager here at Lightstep. Kind of work at the intersection of OpenTelemetry and Kubernetes.
And I'm Adriana Villela. I am a developer advocate here at Lightstep.
Adriana, you know a lot about SRE, I would say, right? You in
Yeah,
your
yeah.
previous
I played
life, you've
around with
kind of run SRE teams and
yeah. I've run I ran actually a Nomad team, so because
Nomad, Kubernetes, same
but
diff,
I,
right?
I but I also spent a lot of time knee deep in Kubernetes. So Kubernetes and I are very well acquainted.
Well, let's tell our guests at home or work wherever you are. It's 2022. You could be working from anywhere. Why from wherever you are, let's tell them why exactly we're talking about the future of Kubernetes operations, because I remember that the only way you would know anything about what's going on in Kubernetes is you'd have to install a ton of extra metric servers and things like that. Then you would need to just get all these logs, just billions of logs, and put them into somewhere and figure out what's going on when something broke by looking at those metrics and logs. But Clay told me, has told us that there is something new on the horizon for Kubernetes observability. And so I think, Clay, you should tell us a little bit about what that is.
Yeah, absolutely. It's actually pretty exciting. And if you have been in the Kubernetes space a long time, I think you've definitely felt the pain around digging through the log files or kind of trudging through various metrics to like understand what's going on with all these different components and subsystems when something doesn't go well. And traditionally, that's been a metrics and logs story. The new thing is just in the past month in Kubernetes version 1.2.5, new components now are traced, which means there's a brand new telemetry type for different components, which also means there's kind of a fresh take on observability of Kubernetes itself. And that's exciting for a number of different reasons that we'll be getting into.
That's super cool. And I guess we're gonna be able to see these components in action today.
Yeah, we actually have a demo of this. It was a little challenging to put together, to be quite honest, because all the stuff we're talking about is still in alpha at best, I think. There's a little history. There was this isn't the first time that distributed tracing has shown up in the Kubernetes stack, right? In I think 1.24 introduced distributed tracing to the API server component, and in 1.25 they've added that into kubelet as well. So previously, this was useful to be able to look at gRPC traffic between API server and etcd, for example, right? But now we can actually go a step further and trace between the kubelet and container D on a host in order to, or I'm sorry, on a node, in order to look at, all the different operations that are, all the different kubelet operations that are happening, right? And that's what's doing everything from deploying pods, scaling, getting statistics. There's actually a ton of stuff in there that we'll be able to look at.
So basically, when your pod deployments go caca, this should give you that extra bit of visibility to figure out like what's
Yeah,
going on.
or let you see, um, hey, I've got 100 node or 1,000 node cluster. Which node is slow? These are questions that are you can answer them with logs and metrics, but at scale, especially, I think that's when you start to run into kind of these edge cases where you really need the detail of traces in order to be able to look at those things in context, right?
Yeah, absolutely. Cool. I'm excited to check it out.
Well, let's go ahead and look at stuff. My favorite hobby. So what I've got here is a dashboard running in Lightstep that is tracking these kind of 7 things, actually. So we're looking at API server rate, we're looking at etcd rate, we're looking at latency off the kubelet, and then we're looking at API server spans. And then we actually have a couple of things over here, and these are not these right now are not being traced. So let's see if we can figure out why. So what we're doing is we're looking at the kubelet service, and then we're looking at operations on kubelet. So let's play with this for a second. So if we group them by operation, we should be able to see all the different operations. So yeah, we have container status, list containers, version, list containers, list pod sandbox, container status. Looking for container starts, but maybe it's, oh, you know what it is? It's not here anymore because I haven't started a container in a little while. So we can explore this a little bit. And what was it? Runtime v1, runtime service, container starts, runtime. Nope. Copy. So if I jump back 30 minutes. Oh, start. No. Why did it go away? Start container. There we go.
So what are we looking at here?
So in this case, we're looking at spans coming off of the kubelet where it's trying to start a container. And we can actually see that there was some interesting stuff here. You notice we have these, we've split this out into percentile latencies. Keep in mind, this is a small cluster. This is 3 nodes. There's 1 server and sort of 2 workers. I'm actually running this in K3S just to make it a little bit easier. But we can go and we can see, you know, here's our P50, P95, P99, P99.9 latencies plotted out. It's not a super continuous chart because, well, it's not a super continuous query. We're not starting that many things. But so what we can do is we can actually switch over to maybe a more useful visualization. You know, a line chart's not going to give us a lot here, but we can look at a heat map, and then we can actually inspect these individual, you know, buckets. So here's one that, you know, took a while, and we can jump in and we can see where here's the kubelet client talking to container D, and we have some informative messages on the side. So we can see the job, we can see what the RPC method was. One thing, you know, if you're coming into this and you're more familiar with sort of the observability and the tracing side, one thing you will notice is there's not a ton of detail on these spans from the services, right? These are really just using the automatic gRPC instrumentation that's available in OpenTelemetry Go. So it does make it a little challenging to do interesting stuff like aggregate multiple ones of these together. You're really kind of limited to just that service and operation. So in this case, we're looking at the kubelet latency itself, and this is a pretty broad query. So we're not really aggregating this by anything. We're just looking at, hey, here's all the operations. And you can see in the heat map where most things are happening very, very quickly. But we do have some, actually like multiple minutes up here where it's trying to do something. And now there's a couple ways that you would investigate this normally, right? If you were looking at this just through like a metrics point of view, you could see those sort of, outliers and see like, oh, I've got something that took 7-10 minutes or whatever. But you might have to then go spelunking for logs to try to find, what is the deeper thing going on here. In this case, we're actually able to kind of ask some more questions just to the data in this interface. So we can, instead of just looking at the service, we can group these by operation, and we can see all the different things here. And then we can look at this and say like, okay, the average for like these GET requests is really, really long. So here's one where it's a GET. It took 7.93 minutes. Let's jump in. And in this case, instead of just the gRPC, this is using the HTTP instrumentation. So we get a lot of stuff for free here, as you can see. We can see like status codes. So if we wanted to go back in, we wanted to make a histogram, or we wanted to see like, based on the status code, like what's our 200s versus 500s, we could do that. But we're also able to go in here and actually look at these URLs and see, hey, what was it actually trying to do? Look at the user agent. And if we knew, for example, I don't think these URLs are pretty unique or like scope per request, I want to say. So not as useful in terms of trying to pick something out. But in the future, or, I could go in and I could use a regular expression, for example. If I knew there was something interesting in these URL patterns, I could use a regular expression to kind of pull that out and then monitor that or even alert on it.
Right. Now, just going back to how this is working. So you were saying that this is leveraging the auto instrumentation for the Go libraries.
So yeah, it's using the Go gRPC, Go HTTP instrumentation libraries and OpenTelemetry.
So there's from your understanding, like there's been no additional instrumentation added in.
There's not really a lot. There doesn't seem to be any that I've really noticed and kind of looking around at this. Cool. I can show you, we can look actually real quick and see how this, we can look really quick and we can see kind of how this works from a configuration standpoint.
Yeah, so I think that'd be really useful to see.
Let's go look at that.
So to summarize in a nutshell, like the configuration for this is basically there's some provisioning flags and there's some configuration files, right? That that need to be
set up first.
Set up in order to enable this functionality. So it's not available free with purchase yet.
It does require a little bit of finagling. So there's kind of two major parts to it, and I'll walk you through. What I'm actually going to show you, this sample code will be available, but not by the time you see this video, this webinar. If you come back at KubeCon, though, if you come to our lightstep.com/KubeCon site during KubeCon, there'll be a link to this, and you can download this and try it yourself. So there's three major parts, and we'll look at sort of the server configuration here. We need to, and I'll just walk you through how I've done this, because this isn't necessarily how you would do this in every case. If you were doing like a full fat kubeADM cluster that you're running on your own hardware, that's going to be broadly the same as this, but there will be some slight detail differences. If you're using managed Kubernetes, I think you might have some, I'm actually not sure how possible this is with a managed Kubernetes service, because one, a lot of them don't have 1.25 in sort of a stable channel yet. Two, in addition to passing in several flags to the API server, to etcd, to containerd, you also need to provide configuration files onto the nodes themselves. So I'm not an expert on every single managed Kubernetes service out there, so this might be very easy or maybe very challenging. Either way, let's talk about how I did it with this. I'm using DigitalOcean because it's honestly just very straightforward to use DigitalOcean to create a VM. And for some reason, that has gotten really challenging with every other cloud. So we're building we're building 3 servers, Ubuntu 2204, 2 vCPU, 4 gigs of RAM each. The first thing we actually do is we install the OpenTelemetry collector. And the reason why we're there's really 2 reasons that we're doing this locally. One is that given that everything, given that containerd certainly is like running at the node level, etcd is running at the node level, right? There are even things that are kind of managed in pods, like having the actual, effectively, since we're talking about node-to-node communication or things that are happening on nodes, we really want to have that telemetry be collected at the node level. Now, you could use a daemon set or things like this, but what I found at least is trying to certain things where you set up tracing, and if there's no, like in certain Kubernetes configurations, if you're trying to set up tracing and there's no actual endpoint listening, then it can, you'll either cause things to kind of like spin forever, or you'll get other various problems. So in this case, just to make it more straightforward, and this is kind of, if you were kind of deploying your own Kate server, this is probably what you would want to do. You would want to have just a node level collector that was kind of managed, baked into your baked into your deployment image or whatever. So
okay, so it's not running on the cluster, but it's
right,
running.
we're just running one collector per node for this. Now that doesn't prevent us from running other collectors.
Right.
We would just need to make sure that the ports are different.
Right. So like technically you could be running one collector per node and then feed that into like a collector gateway that would then
exactly. There's a ton of different OpenTelemetry collector deployment options, and one thing you could even do probably is you could use. I would actually imagine what you could use is have a node collector that you either deployed as part of the image or through a daemon set, and then use like sidecar collectors for your applications that would would take telemetry out of your pods and then send them to that node collector, and those node collectors would forward them elsewhere.
Right.
So a lot of different options here. Have you heard of any other ways to do this, Clay?
Yeah, I mean, I think the one that I've heard the most about is the collector gateway approach, which I think is getting a lot of traction. But yeah, that about wraps it up.
So we go through and we have to do our setup, right? We put our collector on there, and then what we need is we need to pass a couple of different configuration files over, and these are the API. You need a config file for the API server and a config file for the kubelet. So we can look at those real quick. The API server configuration is fairly straightforward. It's just this little config file right here. You need to define an endpoint, and you need to define a sampling rate per million. So in this case, we're doing 1 million so that we sample everything. In production, you might want to consider, a smaller sampling rate, although keep in mind the way OTel tracing works is the default, I believe, is parent. Trace ID is parent-based. So if, a request came in and was sampled, it would the children would be sampled as well. But in this case, since this is for a demo, we just start pulling in everything and going from there. Now, our other one was the kubelet tracing. This has, in an extremely Kubernetes fashion, a slightly different syntax. Rather than, if you notice the distinction here, kubelet tracing versus API server tracing. So for the API server tracing, it's a tracing configuration kind. For kubelet tracing, it's kubelet configuration, and then we enable our feature gate through the config. But then after that, it's the same sampling rate per million, endpoint, da-da-da-da-da. Once we've done that, we copy those over to our known locations. I'm modifying our collector config. And then in this case, we have to install K3s, which is maybe a little, there's a lot of text in this line, so I'm just going to kind of walk you through the important parts. First, we need to tell the API server to turn on the API server tracing feature gate. We need to give it the path to the config file. We need to tell the kubelet to enable its feature gates and give it the path to the config file. And then if we want to trace into etcd and containerd, we need to pass etcd a few arguments. There's experimental and enable distributed tracing. There's experimental distributed tracing address and experimental distributed tracing service name. And then here's some K3s stuff that doesn't matter. Now, one thing you might notice is there's nothing. I'm not passing anything to container D here. Um, K3s will ship with can ships with container D as like a binary. It's sort of packaged together, so you don't have to manage container D separately. It just kind of installs it for you. So what we do is the actual config for container D for tracing, and that is in a config file. So what we can do is we can go in, we can set up our container D tracing by enabling the OTLP plugin, enabling the tracing plugin, and we're telling it, hey, where to send stuff. And then through the magic of copying some files around, I combine the two together, and then it just starts working when you restart K3s. So that's what this stuff does.
Now, is there a difference? Because I noticed the other config files you were using gRPC to connect to the collector, and then the container D, container D configuration you were using HTTP. Is there a reason why there was that difference, or does it matter?
I feel like I was having problems with gRPC somehow, but I actually don't know. I feel like I was having problems with gRPC, and so I
Gotcha.
switched to HTTP. But it just goes to show you, it doesn't matter how you actually get the trace data, because we saw like, oh yeah, you've got gRPC, the traces are connected. But once you've done this, then actually it's pretty much just fire and forget. Like you boot up, K3s runs, everything starts getting traced, right? We can also look at the OpenTelemetry collector config here. So again, this is pretty straightforward. We're just using an OTLP receiver with gRPC and HTTP open. One other thing I'm doing is I'm adding in a resource detector to get the host name of stuff so that things are appropriately tagged based off of what kubelet it came from. And that's kind of it. So once you've done the config, it is very, it sort of just works. And we can see if we go back over, if we go over into, okay, so let's actually install a couple things onto our cluster and see how that changes sort of the telemetry we're getting out of it. Also, let's see if we can get some metrics out of this. So first off, we're going to install a OpenTelemetry operator on the system, and this is going to help us be able to deploy additional OpenTelemetry collectors that we'll use to do things like scrape pods for metrics. We'll be able to install the OpenTelemetry demo and get an actual application running on here. Great. So we've got our everything deployed. Fantastic.
So you're saying you need the operator to be before you can run the install the demo?
You actually don't need it for the demo, but you do need it for a metrics thing that I'm going to try to do.
Okay.
So let's go ahead and let's look at my Lightstep account real quick. Oop, go on.
The operator is going to make it really easy to set up configurations to scrape the various Prometheus endpoints of all these different things that we've turned traces on for.
So it's more. It sounds like it's more metrics focused than the operator.
Yeah, in this case, we're going to use the operator to grab Prometheus style metrics, but turn them into OpenTelemetry and then send those to Lightstep. And so, like,
yeah, you want to tell us what's going on here, Clay?
Yeah, sure thing. So, like, what this is doing is basically telling the OpenTelemetry operator to grab the Prometheus metrics from the kubelet, API server, etcd, other kind of expected Kubernetes components. So it sets that all up, grabs those metrics, and then should send them off to Lightstep.
Let's jump back to Lightstep for a moment and see what we can see on our dashboard, because we've just done a ton of stuff that actually, talks to etcd, talks to the kubelet, talks to the API server. So if we jump in here, we can see these new points where, again, we have some very long running ones. You actually see there's some interesting errors here. So if I jump into the error, this will actually, we can see here kind of the whole journey from the API server down to etcd and back. In this case, we had a 404 because we were trying to delete something. So if we go down here to etcd, Yeah, unfortunately, again, this is one of the problems with the lack of sort of custom attributes on this, is that you don't necessarily get a ton of information about exactly what was going on. In this case, we know that we were trying to do a delete on this daemon set. And it got a 404 instead, so not super helpful. But you can also notice something new here. So if you see now these charts that used to not have a anything data reporting, now if we go in, we can see that there actually are numbers starting to report. This is what happened with the Helm chart that I just installed, right, with the kube hotel stack. So now we're actually getting not just trace data, but we're getting metric data as well from the API server, from our various, various endpoints. And if we jump over into, let's actually.
And that was because you installed the operator.
Right, that's because we installed the OpenTelemetry operator and installed the specific thing that's giving us these metrics is the last thing I did, which was the kube hotel stack. Which you'll actually be able to, I mean, probably by the time this goes up, you should be able to find this. It's in our GitHub under Prometheus Kate's OpenTelemetry collector. Right now, this is in a branch, but because we're working on some documentation and polishing it up to kind of get it out. But what's really cool about this, like I said, is this is giving you effectively the same thing that Prometheus is giving you. But if we go back and we look at our, let's go look at our pods again, there's no Prometheus. There's a Prometheus node exporter. We have kube state metrics, but there's we have target allocators, but there's no Prometheus server. No Prometheus is running here at all, which is honestly one of the most frequent questions I see on the OpenTelemetry Slack is, hey, I've got Kubernetes and I want to monitor Kubernetes with OTel. Like, how do I get rid of Prometheus? So now you can. How about that?
That is super cool. And here's a question for you, for both of you. Does this, I mean, obviously this is like tailored to Lightstep, but do you have to be running Lightstep as your observability backend in order to be able to leverage this?
You don't actually. Nothing that we're showing you is requires. Yeah, actually, that's a good point. Nothing we're doing requires you to be running Lightstep. This is all just built on OpenTelemetry. So I think if I actually do kubectl proxy this, and let me remember. So yeah, like you're saying, everything you're seeing here is in Lightstep, yes. But on the back end, this is all just OpenTelemetry. So if we look at, our pods again, and actually let's look at our config maps because that's where all this is. So we actually, this my OTel demo OTel call is, oh, it's in the wrong. Yeah. So here we go. You see this Lightstep stateful set collector.
Mm-hmm.
So I should be able to.
You remember the namespace?
OpenTelemetry. So if I actually look at the config map for this is where we have the underlying configuration for that collector. And, yes, we have an OTLP exporter pointing to Lightstep because we accept OTLP, but you could go in to the values, YAML, I believe, and you could change all this, right? You could add, you could make this point to pretty much anything as far as, like anything except OTLP, or that you could add in a different exporter to a different backend.
Yep.
And we're actually not doing a ton here in this. making sure we kind of normalize the telemetry somewhat. But most of the magic is coming from the target allocator, I believe. Isn't that right?
Yeah, absolutely. The target allocator is doing a ton of heavy lifting behind the scenes, and it's effectively what's doing the discovery of, we have all of these CRDs. The target allocator automatically picks those up, and then it knows to scrape metrics from kubelet, from API server, from all of the standard Kubernetes components there. So small amount of config, but a ton of stuff going on underneath that's being taken care of for you.
Yeah. And if we look at our notebooks back in Lightstep and we actually, let's build a chart here real quick. If we jump into our metrics, we didn't really look at this before, but now we can actually see that we have a ton of Kubernetes metrics available. So from all sorts of components. So we've got API server here, authentication, core DNS, etcd, various Go, here's our kube config map, kube API server, kube deployments, kube jobs, kube node, replica sets, nodes, metrics, net stats, oh my gosh, there's so much.
Yeah, and the exciting thing is, like, for every single metric type, increasingly, like release over release, those different components are also getting traced as well.
Mm-hmm.
So you can start to kind of pivot between metrics and traces, and it opens up a lot of really interesting use cases there.
Yeah, so we can actually even look at some of these, the container status or container state started, and what would that be? A rate? No. Delta? No. Oh, because we haven't started anything since the start of reporting. All right, that's important life lesson. Make sure that the thing that you were trying to measure happened after you started measuring.
Yes.
That said, let's go back to where we started. Let's go back to our tracing dashboard here, and let's pop this down 30 minutes. And you can see now we are seeing all of our fantastic stuff. We're seeing, except this for some reason. Still got to work on that one. Like I said, still in beta, folks, but be ready in 2 weeks. But you can see now we have our API server stuff. We're actually able to look at the metrics, and we're able to look at the traces. And by bringing these together, not only does it really help us, kind of dive down and look at, more detailed problems, but in the future, and I think really that's what, if we think about it, we're not talking about the present, right? Because we've looked at what you can do in the present. It's cool. Like, it's neat that we can do this stuff. But I don't think that, I wouldn't tell you to go out and like throw out everything you know about Kubernetes monitoring today and start and turn on tracing and go from there. But I think what we can see is the potential of this as a way to inspect and understand the behavior of your cluster, and be able to kind of look really finely scoped at just, details, right? And I think that's really exciting for the future.
Yeah, I totally agree. And I think this is really cool because, for people who want to mess around with this, this gets their foot in the door, right?
Yep.
Into like Kubernetes metrics and tracing early. And then I think it'll be cool to see how it evolves over time, because I'm pretty sure we're going to be seeing some really, really exciting things in subsequent Kubernetes releases.
Yep. Well, that said, we are all out of time. Thank you so much for joining us today in this webinar, and we'll be around for questions and answers. So be sure to check us out online. We're at lightstep.com. We're at Twitter at lightstephq. And if you're going to be at KubeCon, either in person or virtually, be sure to check us out there. We're going to have some really exciting stuff to talk about. Thanks, everyone, for showing up, and have a great day.